Hello everyone. Now, let's talk about Ethernet Virtual Private Network, EVPN for short. It is a technology frequently used on VXLAN networks. As a mainstream overlay technology, VXLAN does not define the control plane in the initial draft. Instead, it discovers VTEPs and learns host addresses through multicast flooding. This method is easy to implement, but it creates a lot of flooding traffic. To solve these problems, in the new IETF solutions, EVPN is introduced as a VXLAN control plane. By extending MP-BGP, EVPN defines the several BGP EVPN route types and advertises routes on the network to implement automatic VTEP discovery and host address learning. In this way, VXLAN tunnels can be automatically established and the flooding traffic on the network is reduced. Next, let's look at the implementation of EVPN. EVPN is an extension of MP-BGP. Traditional BGP uses update packets to exchange routing information between peers. The routing information is carried in the network layer reachable information field of an update packet. An NLRI is added to the EVPN, that is, EVPN NLRI. EVPN NLRI defines several types of BGP EVPN routes, including Type 2 routes, Type 3 routes, and Type 5 routes. After BGP EVPN peer relationships are established between switches, the switches advertise the routes carrying VTEP information and host addresses to each other to automatically establish VXLAN tunnels and learn host addresses. We will introduce the implementation of BGP EVPN in several typical scenarios. First, let's see how VXLAN tunnels are set up and MAC addresses are learned on the same network segment at layer 2. In this example, host 1 and host 2 connected to leaf 1 and leaf 2 belong to the same network segment and are also in the same bridge domain. If the VTEP IP addresses of leaf nodes at both ends are reachable and BGP EVPN configurations are complete, the BGP EVPN peer relationship can be established between leaf 1 and leaf 2. After the peer relationship is set up, leaf 1 and leaf 2 both generate Type 3 BGP EVPN routes and send them to the peer. Type 3 BGP EVPN routes are also called inclusive multicast routes, carrying the local VTEP IP address, VNI, and export route target of the EVPN instance. For example, after receiving a BGP EVPN route from leaf 1, leaf 2 checks whether the export RT value carried in the route is the same as the import RT value of the local EVPN instance. If they're different, the route is discarded. If they're the same, the route is accepted. After accepting the route, if the VTEP IP addresses of the two ends are reachable, a VXLAN tunnel is established. In this way, a VXLAN tunnel is automatically established between leaf 1 and leaf 2 through BGP EVPN. How do hosts communicate with each other after the tunnel is established? It is well known that communication on the same network segment is implemented by searching for the MAC address entries. This means that a switch needs to learn the MAC address of the destination host. On a traditional network, MAC address learning is implemented through broadcast data packets. The switch can learn the host MAC address through ARP broadcast requests and responses. On a VXLAN network established in BGP EVPN mode, BGP EVPN routes can be transmitted on the control plane to implement dynamic host MAC address learning. For example, when host 1 is online, leaf 1 can learn the MAC address, inbound interface, and BD of host 1 by sending dynamic ARP packets and generate the MAC address entry of host 1 in the local MAC address table. Then leaf 1 will send Type 2 BGP EVPN routes to leaf 2. Type 2 BGP EVPN routes are also called MAC IP routes, carrying the local host MAC address, VTEP IP address, VNI, and export route target of the EVPN instance. After receiving a BGP EVPN route from leaf 1, Leaf 2 checks whether the export RT value carried in the route is the same as the import RT value of the local EVPN instance. If they are different, the route is discarded. If they are the same, the route is accepted. Leaf 2 generates the MAC address entry of host 1 in the local MAC address table according to the MAC address, VNI, and VTP IP address of host 1 carried in the route. After this process, Leaf 2 can learn the MAC address of host 1. In the subsequent forwarding process, when Leaf 2 receives a packet destined for the destination MAC address of host 1, Leaf 2 searches for the outbound interface in the BD to which host 2 belongs. Because Leaf 2 has learned the MAC address of host 1, it confirms that the VTP IP address of Leaf 1 is the outbound interface. Then, Leaf 2 performs VXLAN encapsulation based on the BD and outbound interface and forwards the packets to Leaf 1. After receiving the VXLAN packet, Leaf 1 decapsulates it to obtain the inner packet, searches for the outbound interface in the local MAC address table based on the destination MAC address of the inner packet, and sends the packet to host 1. We learned how BGP EVPN is used to establish VXLAN tunnels, learn MAC addresses, and forward packets at layer 2 on the same network segment. Next time, we will show you how to use BGP EVPN to establish tunnels and forward packets at layer 3 across different network segments.